The energy future of the world is changing, and people who understand solar technology today will help build tomorrow's energy economy. From Africa to the Middle East and across the developing world, the demand for reliable, affordable, and sustainable energy is growing rapidly. Solar energy storage and emerging technologies such as green hydrogen are becoming increasingly important. India has emerged as a major center for solar deployment, technology, and expertise. India has played a leading role together with France in establishing the International Solar Alliance, headquartered in India, with a strong mission of building solar capacity and skills across developing countries. Hi, I'm Govardhan from Nirvana Foundation. With more than a decade of practical experience in solar engineering, projects, and training, we are bringing the industry knowledge into structured, practical training program for professionals, engineers, entrepreneurs, and business worldwide. Our objective is not simply to teach you how solar panels work. We want you to understand how to design, execute, manage, and build a successful solar business and prepare yourself for the next generation of solar technology. So, if you are from Africa, the Middle East, or any other emerging solar market, this is the time to upgrade your skills and participate in global energy transition. Welcome to Nirvana Foundation Solar Training.
Commercial solar clients make decisions based on one metric, the numbers. Before you can explain panel efficiency or warranty details, you have to prove the financial value of the installation. The foundation of that proof is the payback period. This diagram shows the basic equation. It is the total system cost divided by your annual energy savings. That calculation gives you the exact moment the client breaks even. But this calculation assumes a perfectly simplified environment. In a live commercial project, you have to factor in tax incentives, varying utility rates, and financing structures to give the client an accurate proposal. Let's look at a common scenario. This quotation template shows a commercial system with a gross cost of $50,000. This specific project also qualifies for a 20% government subsidy. A common mistake is subtracting that subsidy at the end of the calculation process, usually after factoring in the total loan amount. Doing this skews the interest calculations and artificially extends the payback timeline. The correct method is to apply the subsidy upfront. The $10,000 incentive must be deducted immediately from the gross capital cost. This leaves us with an accurate net system cost of $40,000. Establishing this precise net cost is a mandatory first step. It provides the exact mathematical base you need to calculate the loan payments, depreciation schedules, and the final ROI. The next variable we have to account for is utility pricing. This graphic displays a typical utility bill structure. The left column lists the consumption charge, what the client pays for power, at 15 cents per kilowatt hour. The right column shows the net metering rate, what the utility pays the client for excess power, at 5 cents. You cannot calculate the total solar production value using only the higher rate. The system produces energy that travels in two directions. The tower consumed by the factory offsets the 15-cent rate, while the excess power sent out to the grid earns the lower 5-cent rate. To generate an accurate proposal, you have to split the total generation into two distinct buckets. We categorize these as self-consumption savings and grid export revenue. Now, apply these concepts to a new scenario. The text on screen outlines the parameters. A 20 kilowatt system generating 30,000 kilowatt hours per year. The gross cost is $40,000 with a 15% subsidy. The client self-consumes 80% of the energy, offsetting a 12-cent tariff, and exports the remaining 20% for a 4-cent net metering credit. Take a moment to pause the video. Grab a calculator and determine the net system cost and the year one payback period for this specific project. Let's walk through the math. Here is step 1 on the whiteboard. We establish the net system cost by deducting the 15% subsidy, which is $6,000, directly from the $40,000 gross cost. That leaves a net system cost of $34,000. Next, we calculate the self-consumption bucket. 80% of the 30,000 total generation is 24,000 kilowatt hours. We multiply that by the 12-cent tariff, yielding $2,880 in savings. Then we calculate the grid export bucket. The remaining 20% of generation is 6,000 kilowatt hours. Multiplied by the 4-cent net metering credit, that generates $240. Finally, combine those savings for a total of $3,120. Divide the $34,000 net cost by that total, and we get a precise payback period of 10.89 years. This cheat sheet outlines the exact formulas we just used: the baseline ROI, the payback period, and the tariff blending method. Keep this reference handy for manual calculations. Once you understand how these variables interact, you can automate the workflow. AI tools like ChatGPT and Notebook LM can instantly process these variables and generate the full financial breakdown for your proposals. The Nirvana Foundation teaches this exact process in their Solar Business Accelerator course. Module 1 expands on the economics we covered, and Module 4 shows you how to integrate AI tools to speed up your sales process. But the math comes first. You have to master the solar economics manually before you can safely verify the numbers an AI system generates for your clients.